Hi, I'm Carrie James. I'm interviewing for the radiology instructor position. I'm going to be talking today about the X-ray tube, X-ray production, and Bremsstrahlung and characteristic radiation. First of all, we have this device. It's an X-ray tube, and it is inside the X-ray housing. This is the essential element for X-ray production. If you don't have this, you can't produce it. And X-ray production is a very inefficient element of producing X-rays. We only get 1% effectiveness out of this thing. And if you had anything with 1% effectiveness, you'd probably get rid of it, right? Well, the benefits outweigh the ineffectiveness of this, because when we're producing X-ray, only 1% of what we're doing is actually an X-ray. The rest of it's heat. 99% of this production is heat. And if you look, we have two ends of it. We have the anode end and the cathode end. And if you look at a battery, you ever noticed a battery? It has a positive and a negative side, an anode side and a cathode side. So if you're using a battery and you only had a positive side, will you be able to use that battery?
No.
No. You have to have a negative and a positive side. Why do you have to have negative and positive? Because opposites attract. It's the same principle with the X-ray tube. Okay, same principle with magnets. Okay, you put two like poles together, what happens? They repel. But with the magnet, if you put the opposites together, they attract. So that is an essential element when it comes to the X-ray tube and X-ray production. Without that potential difference between positive and negative, the electrons are not going to cross over to interact with the anode. And the anode is made of tungsten. Tungsten's a very heavy metal, has a high melting point, and we use that for X-ray production. Okay, so a little bit about this so that you can understand. So we have the cathode side, which is the negative side, right? And on that negative side, we have a filament. Light bulbs have filaments, okay? What happens when you put energy to this filament?
It lights up.
It lights up because electrons are flowing. The same principle with an X-ray tube, okay? If you were to grab this after it has been lit up, what's going to happen?
It's going to be very hot.
It's going to be very hot because that's what's happening on the cathode side. We're creating this heat. We're burning off electrons to be drawn across to the positive side, to the anode, okay? So, long story short, we're burning off electrons at the cathode side. They're drawn across to the anode side, which is positive. So we have a very high potential difference between the cathode side and the anode side to get those electrons to come across, okay? Once they hit the anode, we're producing two different types of radiation, okay? The first one is Bremsstrahlung, okay? I'm just going to draw a very simple atom, okay? In the very center of this is the nucleus, right? Okay? And we have electrons in each of these. I'm not going to be really accurate with this. So we have electrons orbiting the nucleus, right? So when we're producing electrons at the cathode side, we then energize the anode side and cause these electrons to come across, okay? And they're going to interact with those tungsten atoms, okay? If this electron comes in, breaks and goes another way, this is called Bremsstrahlung. It's interacting with the nucleus of the atom. Well, how is X-rays produced out of this? Because right now we've just got a scattered atom, electron, scattered electron. So how do we get an X-ray out of this? Well, let's imagine we're at the beach. We're all playing on the beach, running around. We are playing volleyball, let's say. So you're sitting there, I'm running towards you to get the ball. I've changed direction, and what happens? I go off the other way, but what did you just get all over you? Sand. Okay, it's the same principle here. The reason X-rays are called X-rays is when in algebra, what's X stand for?
It's a variable.
It's an unknown, right? Same way with X-rays. It's an unknown how it's produced. We just know it's happening because it's production, okay? So we have this electron come in, and then we have X-rays produced off of that interaction with the nucleus, okay? That's one way that we have, one type of interaction that we have is Bremsstrahlung, okay? The other interaction that we have is called characteristic. Characteristic. So we've got our electrons. Again, I'm not going to fill them right. Just give us an idea. We have electrons circling the nucleus. And they're not enough. There's an electron filling order. Okay, so in this interaction, we have an electron coming in from the cathode. Okay? Now, what's the difference between this and Bremsstrahlung? It takes a certain amount of energy to make this happen, okay? In this inner shell, we know that the binding energy of the electron that's there is 69.5 keV, okay, kiloelectron volts, all right? So if I was to try to knock this out, this electron out, how much energy would it take?
69.5.
Right, exactly. It would take that much or more to make that inner shell electron eject from its shell to make characteristic X-ray. So we have this incoming electron, it ejects, this one scatters off, okay? When we're thinking about atoms, what do atoms want to do? They always want to be balanced. So in order for this to be balanced, what's got to happen? It's got to draw an electron from another shell. So during that process, an X-ray is made. Then we have to fill that one, X-ray is made, and so forth. Okay? So at 69.5 keV, we know that we're going to produce an X-ray at 70, right? Okay. However, we still have Bremsstrahlung going on. Bremsstrahlung is going to happen no matter what time, no matter what energy we use, because we use different energies in X-ray. We use 50 all the way up to 120 keV, kVp. So when we're doing that, we know that we can produce Bremsstrahlung all through the spectrum, okay? We only have characteristic at 70 and above. Okay, with that, we have what's called a very heterogeneous beam. And what does heterogeneous mean?
In common.
It's in common when it's 70 above. Now, with Bremsstrahlung, we've got different wavelengths. And those different wavelengths are not beneficial to our X-rays. So what we have to do is filter that out, okay? And then we use aluminum as our filter, okay? And that's all part of the X-ray tube, and in a different section of teaching about the tube. Do you have any questions?
No.
Okay.